Thank you. So the title of my talk is Putting the Social into Data Science. And so it's about the relationship between sociology and data science as it currently stands, and how it might develop in the future. Indeed, I would argue should develop in the future. I'll begin by telling you about my background, and I will then follow this by outlining some of the work that I'm currently doing with colleagues at Warwick, and then suggest some ways in which we might strengthen the relationship between sociology and data science. So my field is social informatics, which is a term that was first coined by Rob Kling in the 90s, and he defined it in this way. It's the study of research, the body of research and study that examines social aspects of computerization, including roles of information technology in social and organizational change, the uses of information technologies in social contexts, and the ways that the social organization of information technologies is influenced by social forces and social practices. So it covers a broad range of issues that reflect on the relationship between society and technology, in particular digital technologies. So social informatics, I think, can be very useful for data science in a number of ways, and indeed data science can be useful for social informatics. For me, data science is a tool for understanding how people use some of these new digital innovations like social media. I think social informatics, on the other hand, can inform data science. Firstly, it can tell us much more about how data science is actually accomplished in practice, which I think is important if we wish to ensure that the results that data science produces are usable and useful. And it also can tell us a lot about how data science is being shaped by people, by organizations, and various stakeholders in this field, and perhaps understanding how that social shaping of data science is moving forward, we can help to ensure that data science evolves in ways that maximize its benefits and mitigate or minimize the risks that might be entailed in using it. So I became interested in data science when doing a study with the Guardian newspaper in 2011 about the riots in England in August of that year. I learnt that the Guardian newspaper had collected about 2.5 million tweets collected during that period, and I offered to help them analyse that data set. They were interested in particular in understanding how people reacted to rumours that were circulating in social media at that time. And we then proceeded to examine 7 rumours in particular. And these are the rumours that we looked at. For example, that riots had attacked London Zoo and released the animals, that the London Eye had been set on fire, that rioters were attacking a children's hospital in Birmingham, that the army was being deployed in Bank, ready to quell the riots, Miss Selfridge was set on fire, and rioters cooking their own food in McDonald's. So the Guardian wanted to see, through using this data, how people were reacting to social media, how they're reacting to rumours. And we therefore did a study which involved a combination of computational tools plus some quite conventional sociological methods such as code frame development and annotation to explore 7 different rumours. And with the help of the Guardian interactive digital team, we developed these visualizations of these rumours. Now, what we see here is typical of the start of a rumour, where initially, as these green blobs show, which are tweets supporting a rumour, these are very much in the majority of tweets being posted at this time. This rumour is about the Children's Hospital in Birmingham about to being attacked by rioters. We see a few people who are denying that the rumour is true, but overall the vast majority seem to take it at face value at this time. As we move forward through the timeline of the rumour, we see how the balance between tweets that are supporting the rumour and those that are denying it changes quite dramatically. We get many more people who are questioning and denying that the rumour is actually true. And for example, an interesting tweet during this period was that somebody tweeted that radio and chief medical officer have confirmed the Birmingham Children's Hospital was not being hit by riots. So here's an interesting piece of evidence being offered, if you like, to support the view that the rumour was actually not true. And we find this same pattern in all the rumours that we looked at. And what we conclude from this is that rumours circulating in social media, initially they gather support, but over time, through a crowdsourcing process, a consensus is reached about whether the rumour is likely to be true or not. And I think this was an important result because during that time, several politicians were saying that social media should be closed down because rumours will spread like wildfire and people will be misled and may make decisions that will put themselves at risk. I think our results showed that in fact rumour is not necessarily more vulnerable than other forms of communication to rumour. There is a self-correcting mechanism which helps to expose what the underlying truth of a particular event may happen to be. So that began my interest in data science and indeed social data science. So I will give some examples, first of all, of some social data science research that I'm currently doing. I then want to focus on the topic of human data interaction, which is about how people work with data, particularly large data sets, and use data science tools to explore and extract meaning from that data. And finally, some thoughts about how we can put the social into data science more strongly, which I will argue will benefit both sociology and data science equally. So here is a brief overview of some of the current work that I'm doing in social data science. There is the theme project, which is continuing the work on rumours and which involves Maria Leocata and others. The digital wildfire project, which is examining how people sometimes start viral flows. And sometimes these viral flows are of a rather unpleasant nature. They might be inflammatory, discriminatory, for example, sexist, racist, homophobic, and so forth. And they can cause harm to people who may feel they're being singled out or attacked by virtue of their lifestyle choices, for example. In that project, we're looking at how governance of social media and people's conduct on social media can be improved, for example, by the use of what we call counter-speech, that is to say, by challenging people who post discriminatory content. The Radio 5 Hit List is a show that's been broadcast weekly on BBC Radio 5 Live, and it's based around a top 40 list of stories that have been shared on social media by people in the UK. Now, because the BBC wants to focus on UK stories, we have developed machine learning techniques to geotag content at the country level in real time to make sure that we are using content that's relevant for the purposes of the show. The next image here is meant to reflect the use of various kinds of social data as social sensors, and is exploring how we can use that to be able to better anticipate some kinds of natural hazards better to anticipate than we would be able to do if we just used more conventional physical sensors alone. And finally, we're just about to begin a knowledge transfer project with a company called Metafused, who deliver marketing insights by using machine learning to extract information from social data. So let's go back to Rumours, and here we see some images posted during Hurricane Sandy, which illustrate to varying degrees how difficult it may sometimes be to be able to distinguish rumours that may turn out to be true and rumours that are patently false. One or two of these images may look as if they've been photoshopped, may be fairly easy to detect, but some of the other ones is not so clear. So it is, I think, unquestionable that we need tools to help to be able to identify rumours that are true and rumours that are false. And that is the objective of the theme project, to develop machine learning methods which can analyse large quantities of social media and can, through that analysis, through the use of machine learning, can help to predict whether a rumour is likely to be true or not, to verify the status of that rumour. We define a rumour as a circulating story of questionable veracity, which is apparently credible but hard to verify and produces sufficient scepticism and/or anxiety. To do this, we've collected data sets of diverse sets of rumour stories, and we have then annotated them for linguistic and interactional patterns, and then use these data sets to train various kinds of machine learning techniques and compared which ones perform the better. And we're currently still working on that particular part of the project. These images, by the way, are from the riots data set again, showing images that were posted to help convince people that tigers were roaming the streets of London and that the army was being deployed by the River Thames, both of which of course turned out to be false. So let's look at this in a little bit more detail. So here is what we call a conversational thread. And this is one of the innovations that we've introduced in this project. Instead of looking at individual tweets as a basis for analysis, we use this idea of a conversational thread, which is a source tweet there at the top, and tweets that follow it, which are linked to that source tweet by a reply relationship. You'll notice that this is not a linear sequence, however, that it branches as replies are made to tweets within the thread. So we see branching happening down towards the bottom of this particular thread. So we've used this approach, the conversational thread approach, in our subsequent studies of which machine learning techniques work better for predicting the veracity of rumours. Just to illustrate this a little bit more clearly, here we have a source tweet A, and here is the tree, in effect, that this conversational thread is represented by, with different branches reflecting the more local reply relationships between individual tweets. Now, we need annotated data, of course, to use machine learning if we want to be able to detect the veracity of rumour. We're using supervised techniques because we believe these will be best performing. And this is the annotation scheme that we developed to create training data sets. You see there is a source tweet and replying tweet, and depending upon whether we're annotating support or replying tweets, we annotate it for support or denying or unspecified, the response type, agreed, disagreed, appeal for more information or comment. We have a field in the annotation scheme which reflects the confidence that the person tweeting appears to be showing about what they're posting, and also to note the existence of any evidence that's been provided in order to substantiate the post and might encourage people to believe it because the evidence is somehow itself verifiable. Here's an example of the annotation, a micro-annotation task, which we put onto Crowdflower to crowdsource annotations for the different rumour data sets that we had collected. This is what the annotator is presented with, and then they have a number of options here to record their interpretation of a particular tweet at that point in the thread. And through Crowdflower, we've managed to collect a sufficient number of annotations for the training data sets so we could then use them in order to test different machine learning approaches. Here's a summary of the main categories that we'll be looking at in the next couple of slides, that is to say, labels that identify whether a tweet is supporting, denying, querying or commenting upon a rumour. You can see that in all these different cases of rumours, Charlie Hebdo, Ebola, Essien, the Ferguson disturbances, German wings crash and so forth, we have different proportions of supporting, denying and querying tweets, but the majority, by some margin, in all cases, is for commenting. And we'll bear that in mind when we come to look at the results from the machine learning approaches that we've tested. So here's results that we've obtained from training a number of different machine learning methods on these data sets. So we have two graphs here. One is micro-f by depth, and the other one is macro-f by depth. And what we mean by micro-f is the accuracy of the method without weighting the proportions of the different categories, the different classes. Now, I said that comments were by far the majority class. So in macro F1, we decided we would see if the results are changed in any way if we equally weight the different classes. And so we get, using that equal weighting, we get somewhat different results in terms of performance. What we see, I think, in both cases, though, is that what we call linear or tree CRF tends to work better, especially as we go down more deeply into the particular thread. Now, conditional random fields is a technique which doesn't take an individual tweet as the features of an individual tweet in order to learn the label, but takes that tweet plus the labels on the preceding tweets. So it takes into account the labels in preceding tweets. In the case of linear CRF, we're taking the tweets in a particular branch, the preceding tweets in a particular branch, as the units of input to the classifier. In tree CRF, we take the whole tree as an input to the classifier. We can see that tree CRF seems to work somewhat better than linear CRF, suggesting that using the whole tree as the input for training the classifier is a better approach. So we feel that overall the results so far motivate the use of conversational threads, relationships between tweets, as a way of training machine classifiers, and that also this approach could be applied more widely to a range of different NLP classification tasks. Let me turn now to social sensing and the idea that social media can provide much denser geographical coverage of hazards compared to physical sensor networks. And by documenting personal observations and experiences, we can also record the impact that hazards have on individuals and on the environment. So this seems a particularly interesting way of being able to anticipate and manage natural hazards. And this next project explores that idea. We're looking at flooding, and looking at images posted on Flickr and the tags that were associated with them. So on the left you see an image that might be represent just a normal image of a river under normal circumstances, and over on the right we see an image which reflects the effects of flooding. So when we look at Flickr, we can identify images with different tags which reflect different states of these environments, and we're using these images to see if we can predict more precisely the onset and magnitude of flood events. So just to show some summaries of this data set, this is the spatial distribution of images with risk signaling and neutral hydrological tags uploaded to Flickr over a 10-year period starting in 2004. We can see risk signaling or flood-related tags, flood or floodplain over on the left, and then what we refer to as neutral tags, which talk about nature, landscape, or river and water over in the middle and on the right. So these are the examples of the images and the tags that we've collected in this particular project. Here we see a timeline of those different tags over that same period, monthly aggregated over that 10 years. And finally here we see these Flickr images, the numbers of Flickr images along a time scale that also shows reports by official sources such as the Met Office and secondary weather reports, and indeed official news outlets about flooding events. So we can see here that there might be some correlation between the numbers of Flickr images posted and these flood events, and it's that we wish to explore in more detail in this project. Incidentally, this is led by Natalia Tkachenko, who is a PhD student of mine. And what we see here is a correlation between aggregated neutral hydrological tags river and water together versus the tag flood within what we call flood peak periods, which is a 5-day window around a particular flood event. And what we can see is that as we look at the magnitude of the event measured by the number of uploads of images along this axis, ranging from 10 to 50 to 100 to 125, the correlation gets stronger between these two types of tags. And this leads us to imagine, therefore, that these neutral hydrological tags can serve as a possible sensor for forthcoming flood events. We note that the peak correlation occurs about a day before the actual flood event. So the next step here is to use Flickr data as an additional input into hydrological models that use physical sensor data and see if we can better predict the onset and magnitude and duration of flood events. Okay, so turning now to human data interaction. How do people work with data? How do they interpret and understand what complex machine learning algorithms produce and what decisions they may then make using these data sources? We've been looking at this in the context of the theme project, which is developing a dashboard for journalists to use to help them decide whether stories they find posted in social media are likely to be true or not. So here's an example of the dashboard, one version of the dashboard, which shows different sources that people may consult when they're examining particular stories. To understand what the requirements are for a dashboard that's going to help journalists interpret social media stories and decide on their veracity, we've turned to a tool known as Ethnography, which is the immersive study of work practices. So we can see exactly how work is done under current situations with current technologies, and begin to anticipate what the requirements would be for some new technology in that particular work practice. We note that user-generated content is becoming particularly important in journalistic work, but it presents major challenges for the reasons that I'm sure you'll guess, because it's not all reliable. And therefore it has to be explored and tested, if you like, before journalists can be sure that they can use it to write a story. Using ethnographic practices, we have explored how this is currently done and use that to then determine some possible requirements for the dashboard that will use machine learning to present predicted veracities of these same stories. So user-generated content is used in a number of different ways: resources for leads and identifications of stories, sources for content and also to facilitate the verification of content, and in their own right as a vehicle for publishing news. Journalists are increasingly working in a 24-hour news cycle, and they are finding that they face competition from new kinds of news media players. And therefore there's greater and greater pressure to get stories out quickly, to use social media. But at the same time, they have to be confident that the stories they find in social media can be relied upon. It's one thing to tweet about, say, some cricket players' performance in tests, as we find here. It's quite another to tweet that the Queen has died because you read it on a BBC website. And of course, anybody picking up that story would need to know if that really can be relied upon. So through this ethnographic work, we've explored what journalistic work actually involves. And this summarizes how the process of checking stories and working them up is quite complex, and verification is part of that process from start to the finish. So whilst you may think that the journalistic workflow, if represented in this way, might prioritize checking of verifying leads at the beginning and perhaps at these stages, what we actually find is that verification takes place throughout the whole process. It's never completed until the story is published. And so what we learn from this is verification tools, the machine learning algorithms, and the way that data they produce is then displayed, needs to support the ongoing character of verification if it's going to be really useful. Finally, I want to just briefly talk about ways forward for putting the social into data science. You've probably all heard about the story of Google flu trends, which exposed some problems with assuming that using new sources of data we can predict more accurately certain phenomena like the spread of flu. Google flu trends, using Google Trends data, over-predicted the spread of flu in 2013. And a number of lessons, I think, can be learned from that, which reflect on social data science more generally, and we need to take them into serious consideration. Laser et al. Analysed this problem with Google flu trends, and they concluded that they're not limited to Google flu trends, that research on whether search or social media can predict X has become commonplace and is often put in sharp contrast with traditional methods and hypotheses in sociology. Although these studies have shown the value of these data, we are far from a place where they can supplant more traditional methods and theories. So this, I think, reminds us that there are many important challenges for doing social data science in a way which can actually lead to relevant sociological insights. First of all, making sure that we're sampling all content that can be useful for our purposes. Data wrangling and curation, which means turning data sets into researchable data objects. Interpretation, how do we assign meaning to data that is generated through the course of people's everyday activities, accounting for spurious correlations and the generative effects, because social media platforms tend to shape what people see and also sometimes how they then respond. Trusting algorithms, which means being able to get to the bottom of what a complex algorithm actually does, so we can see how the result comes from the data. This is important for verification and repeatability. And of course, we need to build an interdisciplinary culture with social scientists and data scientists working together. And finally, ethics. Can we follow the gold standard of ethics in social sciences, which means giving participants informed consent over the uses of their data? That looks particularly challenging. So just to conclude then, I would say make the following observations and recommendations, if you like. We need to study more closely how data science is done so that we can learn from that and factor that into the way we develop tools that data scientists will use. This will help to ensure robustness and reliability of the results. We also need to understand more about how that the results are then used by various people, how they become credible when used in policy making, for example. And finally, a question, I think, which I'd like to pose is, as we seem to be entering what people call a post-truth world, where, for example, people claim that the voters' behavior in the US presidential election was influenced by fake news stories that were propagated on Facebook, that people, because they now tend to consume more of their news through social media than traditional outlets, and because these social media sources tend to be selective in the kind of news they present, are we creating filter bubbles or echo chambers that restrict people's access to a more diverse set of sources? And what can we then do about it? And the very last slide. We've often heard in the past few months about experts being wrong, that somehow experts are not to be trusted. How can we as data scientists who claim to be able to produce results that can inform people, that should be used in decision making, in policy making, how can we counter what seems to be a tide of opinion that is less willing to take experts and hence the tools they use seriously? What ways can we address what seems to be growing skepticism about the whole enterprise of trying to understand society scientifically? Thank you.
So are there any questions for Rob? Can I give you? You talked about social media particularly creating echo chambers or bubbles for individuals or groups that sort of either reinforce the beliefs they have or colour their view.
I would say that is a claim at the moment. It's not been verified. And one of the ways I think data science can help is to actually explore whether there are examples of that.
That was exactly my question, so I suppose to sort of follow that up, where do you feel like the responsibility for dealing with that problem lies? I mean, clearly it's not in one place, I suspect, but obviously data science is going to play a big role, I suspect, in addressing it, but do you feel like that's the solution to that problem is going to be sort of driven by the content providers, by the journalists, by individuals, or indeed the wider community?
Well, first of all, as I said, I think we need to test whether the claim is actually true. Can we in some way, say, for example, examine people's access to different sources over time as social media has become more and more prevalent? That will then give us some confidence that there's a problem that we need to address. How you then go about doing it, I think is a difficult question to answer. It may be that we can develop ways that can help journalists to present more balanced stories, and perhaps that will then begin to break down these echo chambers and filter bubbles. At the moment, they don't really have those tools, and certainly I think we could look at if we can do that. That might begin then to redress perhaps the problem that may be happening. And note, of course, that if these filter bubbles and echo chambers are a reality, then of course data science is actually contributing to that problem, because it's the use of data mining, data science, that is helping platforms to create these rather more closed information environments.
Great. Well, if people have more questions, if we could take them offline, that would be great. And this concludes the Faculty Fellow Short Talks. If we could give Rob Procter and Ricardo Silva another hand, that'd be great. Thank you.